So as Tao mentioned, my name's Max. I founded a company called NitroLabs, and we build web products. We build productivity products. Tonight I'm going to be talking about one of our products, LuminPDF, and how we scaled it. So an outline for the talk tonight. First I'm going to talk about what we're building, LuminPDF and what it's becoming. Then I'm going to talk about our initial scaling problems. So what were the things, as the app grew, that we had difficulty scaling? And I'm going to talk about how we overcame those problems. And if there's some time at the end, I'll do a brief demo. So what are we building? We want to build PDF in the cloud. A large proportion of people, almost everyone, uses PDF documents almost every day. And we find that the tools just aren't there for people to sign, annotate, comment, share, collaborate, and work with these documents. There are tools, sort of desktop-based, and there are fragments of tools, but we really think that there needs to be a better solution for PDF. And so this is what we're building. It's cloud-based PDF editor, and it looks like your normal PDF viewer, except you get real-time updates on any of the edits you make. So you can add annotations, you can block out pieces of text, you can make comments, and you can sign the document, and anyone else that has the link is going to see those changes automatically. So you can imagine for someone that's editing a book, any edits they make, the reviewers or the author will see those instantly and can make updates. And the really cool thing is, because it's Meteor, it's real time and it's live. So here's a really, really quick demo video of just, you can see two different browsers open, and you can see sort of the updates being made across the browsers. And this is not localhost, this is real live on the web. So when we first launched the app, we didn't get a lot of growth. Here you're seeing daily page views, and we're looking at like 110 views a day, which for some like blog website or something might be all right, but for a large production scale app, not overly great. Well, once we got our marketing right, we made some strategic partners. We got some serious growth. And if I zoom that out a little, we went from 200 users a day to almost 200,000 users a day, page views, within a week. And so we had some pretty serious scaling issues, as you can imagine. With 5,000 concurrent users, up to 10,000 in the morning, we're making 500 API calls to sort of Google or other OAuth APIs per second, and we had 100,000 new people signing up per day. So what didn't scale? Well, here was our server architecture at the time. We had a blocking Python server and a Mongo database, and we were hitting it with that traffic I was talking to you about. And so obviously it all fell apart. Actually, it wasn't that bad. We had an Nginx proxy on the front doing some caching, but yeah, there was no way it was going to handle that. And so the way we actually got around it, we made the website static, and then we just let Nginx cache it, and so everyone just got the landing page, and then they couldn't get anything else, but at least we could handle the traffic. So they didn't just load, right? They got, yeah. And then we did sort of the textbook thing, which we meant to do, which was sort of scale out the application layer, launch up as many AWS instances as we could, and try and make it work. But as you can imagine, that didn't really work either. So 4 a.m., a few weeks in, these Python servers started going down, and the alerts started going off. And so I woke up and I tried to fix things, and I sort of SSH into the database, and the database is corrupted. Great. All the Python servers are down. Nginx is still running at the front, but pretty much everything had gone down. And so what had happened? As the app slowed down, US traffic came up, at 8 a.m. in the morning. I was in New Zealand, it was early night. People started clicking on this open my file button a lot. And every time they clicked, they started launching sort of third-party API requests on blocking code again, right? And so the app got slower and slower, and they clicked more and more, and we had hundreds of thousands of people just trying to open their file, and nothing was working, right? So the Mongo database slowed, the request rate tripled, all the API providers, the OAuth providers, the Google storage started rate limiting us. And so our servers started logging errors. The database started logging errors. Everything ran out of space. The database got corrupted because there was no more hard drive to write files to, and all the Python servers went down. So we've recovered. I had phone calls from people that morning saying that they'd lost their work and they wanted it back. It was tough, but we recovered. We had the server back online within 12 hours. But I decided it was time for a complete redesign. We had to start from scratch. We had to sort of build a server architecture that was non-blocking. We had to build something that would scale out, something where the log files couldn't corrupt the database. And so we decided to build a scalable Meteor app. And we needed it quick because these Python servers were still running. We needed it really within weeks. We still wanted to keep our real-time functionality. We still wanted our fast response time. We really needed to deal with the rate limiting problem, and we needed something that wasn't going to fall over. Even if the traffic went up an order of magnitude again, we wanted something that we could recover without losing any data. So I got the design developer team on board and scaled out the size of the company pretty quickly and started building as fast as we could with Meteor. And so our sort of first attempt at getting Meteor scaling and running really quickly was this here. We were running on Galaxy, 40 to 50 containers. No problems there whatsoever. That handled the load quite fine. We scaled out, we kept Mongo, but we scaled out a database layer to multiple replica sets. We sort of set up the DevOps in-house just so we could get the right sort of scale. And then we increased the backups. And we started redirecting as much traffic as we could in terms of like high bandwidth traffic, like loading PDF documents or sort of loading binary files directly to their source, be that S3, be that the Google Drive, Dropbox. So wherever possible, we directed those requests away from our servers, away from sort of the whole DNS channel. And any code that wasn't sort of directly application specific, we shifted to workers. So we had a large number of workers running. They were written in Meteor as well, but you know, if they went down, it wouldn't cause the entire app to go down. So we're separating out concerns. As the app got more complex, this is what we're looking at right now. So we've separated the sort of main Lumin app that does the PDF editing from the home and the billing pages. We've built a new tools app that handles our merging, our conversions. And these are all accessible at different endpoints publicly on the web. And we've kept our guides separate. They're all connected to the same database. And we're slowly moving GraphQL, and we want that to be sort of a layer right across, separating our client-side requests from our database. And so I'll just also point out here, like in red, everything in red you see there is running on Galaxy, and everything in red or sort of that dark green color is Meteor code. This is sort of my vision for what I would like to see within the next year. So I'd like to see GraphQL as the separator between our client-side facing apps and our server. I'd like to see a layer of logic. Of course, this logic here would be microservices architecture if you zoomed in, but a layer of single logic separating our client side from our server. And I'd like to keep the cloud storage model where we're still offloading high bandwidth to other providers. So the current performance of our app, we have 17 million users and growing rapidly. We're still growing at 60,000 new users per day. On a typical day, we're at 5,000 concurrent users, which can come up to 10,000 concurrent users depending on the day, the time. And remember, these users are all annotating, right? So they're generating a lot of database mutations. They're typing text in live, which is being synced across multiple devices. And so we're getting 10,000 Meteor subscriptions per minute, or up to, which is all being handled by Galaxy, and it's fast. It's our method response time on most of our methods is still 10 milliseconds less on some of the other methods. And the really cool thing is, since we've moved to Galaxy, we've had pretty much zero downtime. No one's complained to me about downtime. We haven't picked up any downtime on Pingdom or any of our monitoring tools. There may have been outages, but nothing that's caused us any grief whatsoever. So I would like to sort of shift direction here and talk about scaling an app, not just at the application layer, but sort of as a system of interconnected parts. Because, like I said, when the service went down earlier, it wasn't really because our application layer was failing. It was because we couldn't get enough requests to the OAuth providers. Our Mongo database was slow, and our logs eventually really destroyed everything because we ran out of storage for them. And so I think it's really, really important when you're developing an app and when you're preparing to scale an app, not just to think about the business logic and scaling the Meteor code, because plenty of people have shown that it can be done. I think it's really, really important to think about scaling these individual components. And even if you're not quite ready to scale, be ready to scale these individual components. So I'm not saying you have to have a huge MongoDB, but make your DB in a way that you can scale it out. So key lessons: scale each component individually. And I think it's also really important to invest some time in logging and performance management. So we talk about, as developers a lot, not prematurely optimizing. And I totally agree. But I think it's really, really important to set up your logging prematurely and set up your APM prematurely, even if you don't need it. Because once the traffic comes, it's too late. And so those things are things that you should be doing straight away. You should be setting up great logging and great APM. And consider the worst case scenario. It's not too bad for an app to slow down, but have a recovery plan and position if you get hit by high traffic and you have to deal with it. So with that, I'm going to jump over to a quick demo. So here you can see, this is the LuminPDF editing app. And I have one of my friends is writing this book, and I wanted to give him a little bit of feedback on the book. And so I want to just start by sort of crossing out the contents because I'm not a fan of that heading. And I can see here this fundamentals heading looks a little larger than maybe it should be. So I'm going to go ahead and highlight that for him. And we can change the color of that to something else, blue. And then I really think that we should add an image in here. So I'm going to go and drag like a big colorful box. And we're going to just, so that the editor can see this and say, that should be an image. And we'll add a comment underneath that saying, let's see, replace the colored box with an image. And again, all this would be happening in real time, so anyone else with the sharing link open would be able to see this comment, and they would be able to reply back to it. Just like Google Docs or something that's equivalently real time. And so you can go through and you can add text, as you can imagine, like most PDF editors will allow you to do. And say if you wanted to delete pages, we have this new feature coming. I want to show you this. I just mentioned it earlier in the presentation. It's a brand new website which we want to incorporate into LuminPDF eventually. And it's our tools site. So with this, you'll be able to compress files, convert files, do OCR, split and merge, and eventually all integrated within the LuminPDF editor. So here you can see our menu. This is all written in React, by the way, React Meteor MongoDB backend. And some of the tools we have here, it's sort of in live beta, so not everyone knows about it yet, but it is live on the web. You can find it at tools.luminpdf.com. But you get the idea, and hopefully you'll check it out, try it out. It's reliable, it works, it's great. Compression ratios are fantastic, so enjoy. All right, thanks. Initially, we got it done in about 3 to 4 weeks. Keep in mind though, we had some of the PDF, some of the client-side PDF JavaScript code written, which we could just copy over. But yeah, the bulk of the Meteor app was done 3 to 4 weeks. And then I would say a year of polishing on top of that, making sure everything was working really fine. So it depends on what the route or the method's doing. A lot of it was database tuning. So a lot of these methods go ahead and call the database, and so we were pushing really, really hard to get our database at sort of 1 to 2 millisecond response times. Definitely took a year or two of tuning and working, and making sure the indexes are in the right place, and we're only ever calling methods on the database that could be indexed or that were indexed. Other than that, just a lot of tuning and a lot of scaling.